This is your basics of dimension placement handout. It is a shortcut method, but basically all the rules of dimensioning in one spot for you to go over, learn from, and use. So you might want to print this out. Make sure you don't break any of these rules in your homework. I will use these homeworks instead of noting on your week 7 homework what you did wrong. I will just say if you forget to put in the overall dimensions, I'll just write number 5 on there, and you can look up here and you'll see number 5 is rule number 5 is provide overall dimensions. So it's a faster way for me to grade your homework. So I'll go through this. You can also use this on your next test. But I've grouped it into different categories. For instance, the first paragraph there, aesthetics. Before you can dimension correctly, first you have to pick the best views. So you pick the best views that shows all the features that you need to dimension, and orient those views upside down, right side up, whatever. You're to pick that part. It could be modeled any way, and you turn it around on your draft view and choose your best front view. From that, you get your top view, your right side, whatever, your section views. So you have to figure out what the best views are and how to show them, how to orient them in your paper. Do all that first before you throw a bunch of dimensions on, because if you rotate a part afterwards, after you've dimensioned it, the dimensions don't like to always rotate correctly with it. So you'd have to redo it. Aesthetics is first. Select your views to aid in dimensioning the part. Pick a good front view. Usually the front view is the front of the part, unless it's a part that already has a front, like a car would have a front. So we'd keep the front of the car as a front view, even though it might not be the most descriptive view. And the car has a top, so you'd always use that as a top view. But if you were doing just some weird object, okay, puck light here, the top view, I mean, this thing can be sitting this way and the light's facing down, or it could be sitting upward. So there is no real top to it. Probably the best view would be, the most descriptive view would be this as a front view. So you pick your best view, and that leads to all your other views. Number 2, dimension values are either placed horizontally or vertically. So with NX, you have an aligned view set up, aligned text. So the text, horizontal text would be upright, and vertical dimensions run vertically along the dimension line. If you do a leader line, it will be at an angle, and you'll have to straighten the text out, and make it horizontal. When you're doing your hand sketches, like for your final report, just make sure you follow the same rules. So you only have horizontal or vertical text. Number 3, dimension spacing. First dimension is about 2 text heights away from the part boundary. When you're in a CAD program and you're zooming in and out, you really don't know how big everything is in real heights, so on real scale. So you just have to go by what is compared to. And if you have your text set to the right height in your CAD program, then you can measure everything in sizes of text. So you can compare everything to the text. You can compare your arrowheads, your gaps in the dimension line, everything. Compare it to the text height. Spacing between dimension lines can be smaller or shorter. You can usually stack your text pretty close together, but don't crowd the part boundary. Locations, number 4. Rule number 4, dimensions should be placed between the views as opposed to beyond them or on them. You never want a dimension going across the front of the part, okay? Keep the dimensions outside the part. Here's the part, outside the part, okay? Most of your dimensions are typically put between the views, so between the top and the front view, that's where the dimensions go, between the front and the right side. But I mean, that rule is broken often because a lot of times if you have a feature on the left side, you don't want to drag it all the way to the right side of the part. You'll just bring it out to the left side. Keep a empty zone though around the next to the part boundary or the border of the sheet. Don't crowd the border, don't crowd the views. Number 5, provide overall dimensions. So you need overall height, width, and depth on each part. Number 6, place dimensions on the view where the feature is most apparent. So this is sometimes called contour dimensioning. Pick the view that has that dimension, that where you want to put that dimension, but pick the best view to put it on. Typically where that feature is seen as a shape, not as just a couple lines. Number 7, make sure you always put your shorter dimensions near the part outline. So it should go short dimensions, longer, longer, longer as you go away from the part. If you put the long dimensions in toward the part, then you're overlapping lines in text a lot of times. And it looks messy. Number 8, part features should be sized and located in the same view. So like a hole that's going through part, you want to size it and locate it with your two dimensions from 2 different features in the same view. Basically, when you're dimensioning a feature, you want to look at one view if possible and find all the dimensions for that feature in one spot. You don't want to make the person look through 6 views to get all the information he needs. Extension lines start with a small gap near the feature being dimensioned and extend about 3 millimeters or 1/8 of an inch beyond the dimension line. NX does this automatically for you. If you are working on your own hand sketches, then you have to make sure you do that correctly. Center lines can be used as an extension line. Once the center line exits the part's boundary, last feature on that part, then it can become an extension line and it loses its center line type. Arrowheads for your hand sketches, make sure you make them narrow and solid. Doesn't take that long to fill them in, but it makes it much more readable. You can't just draw a bracket like this and put a number by it, okay? Or I can't tell the difference between your extension / dimension lines and your regular lines. So you should be able to tell the difference between dimension, extension lines, and object lines. These sizes and arrowhead types are already defined for you on your dimension title blocks that I've given you. Number 12, all dimensions should be expressed in decimals. This is for any homework we do, for your final projects, okay, also. So decimals, no fractions. Standard text heights, whether you're working inches or millimeters, it's 5/16 of an inch high or 9 millimeters. That's a industry standard. Everybody goes by, and it's related back to the old days when things were all hand drawn. Since when we copied drawings with the blueprint machine, blueprint machines weren't that good at reproductions. Okay, the reproductions were of worse quality, worse resolution than the original. So a lot of times lettering suffered. If people put upper and lowercase letters in, a lot of times the lowercase e's and a's and o's all look the same. I couldn't tell the difference. So what they did in the industry is they said everybody use uppercase letters. That way there's not bigger and smaller letters. And the typical height was 9 millimeters tall or 5/16 of an inch. That standard is loosening because nowadays everything is Xeroxed or scanned in, and basically copies are just as good as the original. I see industry now using lots of different fonts and different sizes text too, but it's all usually easy to read nowadays. Because of this, and when we're using 8.5 by 11 printouts in class, we don't have a lot of room on the template to put a lot of information, dimensions and stuff. So what I did is in your template, I actually shrunk the size of the text down to about 60% original. So I think it's 6 millimeters instead of 9 millimeters. Just in case you're wondering why everything looks kind of small, if you notice that. And I shrunk the arrowheads too to be the size of the text. In your hand sketches, make sure you follow the rule. Don't make your text so tiny. I know some of you like to draw text that's 3 millimeters tall, and normal people have to be able to read your drawings. Units. English units are in inches. Metric units are in millimeters. They may be in different units. They may be in yards or in meters, but in most engineering practices, it's in inches or millimeters. Unless you're a civil engineer, then you're working in kilometers or miles or meters. 2 decimal places is typical for non-critical dimensions for inches. So if you wonder, well, what's the tolerance note for inches? Well, it's usually two significant digits to the right of the decimal. And it's usually one significant digit to the right of decimal for millimeters, since they're smaller than inches. Look at number 16. Use the following values for general tolerancing. If they give you two significant digits in the book, we typically, use that amount. I know the counter block, they only give you one significant digit, but I made that the 2 because that's standard. So if you look at number 16 here, not only is it two significant digits, but those digits are numbers. So you could have two significant digits that's 0.02 plus or minus 0.02 inches, or it could be 0.01 inch, or it could be 0.05 inches. How do you know what it is? Well, if you're doing the part, you probably know what the tolerance is. I mean, if it's your company that's doing it, you probably know what the tolerance is. If you don't, then you take your caliper and you would measure. Set it to a caliper is set to inches or millimeters with a button here. You make sure you close the jaws and you hit 0, and that should zero it out. And then you'd measure something. How wide is this pencil? Well, you'd open it up. Unlock that there. You open it up, you close it, and you write it down. 6.95 millimeters, and you do that several times. Okay? If you do that several times, you're not going to get the same number every time, but it's going to be close. And mine is varying between 6.91 and 6.95. Okay? So I know that it's varying about plus or minus 0.02 or 3. So there I've just determined what my tolerance is on a wood pencil. And that's how you determine the tolerance for any of your parts for your final project. Take an average of about 5 dimensions on the same part. Throw out the largest dimension and the smallest dimension, because you might have made a mistake. Average the remaining ones, and that will tell you not only how big the part is, take the median dimension, but it also will tell you what your tolerance is, so you can write that in there. Metric tolerances have a 0 preceding any number that's less than 0 or less than 1, so you would have a 0 before, like a 0.5. If you need more significant digits, you just add them in there. Remember your dimensions on your drawing. If it's 1.00 inches diameter, then you need a tolerance note of 0.0 something, okay? Usually 0.01 or 0.02 or 0.05. It can be any number you specify, but it has to have that significant digits in your dimension as well as in your tolerance note. Number 17, let me give you an example of 17 with the taper collar. So number 17 is talking about a cylindrical object, which the taper collar is. And it says, cylindrically shaped parts should be dimensioned as follows. 17A, internal diameters are placed on the rectangular view of the cylinder in section view. Here's the section view. This is called the rectangular view of the cylinder because the cylindrical parts look like a rectangle, okay? So this is where we place our rectangular view of the cylinder dimensions, which is designated as a diameter. It says, 17B, external diameters of the part are specified with leader lines to the circular views unless the internal diameters are revealed by sectioning the rectangular view. So if we had this part and it did not have internal features, then we would dimension all of the external diameters with a leader line such as this. Okay? That's how we would do it. But since we do have a section view, we end up putting the internal diameters like 2.0 and 3.5 and on the section view too. Section views are just very handy for internal and external diameters. So if you put an external diameter on like 6.5, 4.0, you don't want to put it in the circular view too. Okay, that would be redundant. Number 18, leader lines should not be vertical or horizontal. So if we look at this, if we have a leader line, we don't want them vertical because they tend to bleed in, even close to vertical, okay? You don't want to do this because it tends to bleed in. That leader line just sort of disappears, and you might find the arrowhead, but the leader line's hard to see. Horizontal, same way, it kind of hides in drawings. Because in drawings, oftentimes there are a lot of vertical and horizontal lines to hide behind. So don't do that. Always bring it out at least like 15 degrees, usually from horizontal or vertical. It says avoid breaking the back of a leader line. Sometimes when people hand draw things, they say, well, that's not very neat. And they'd go in here and they would breaking the back of the leader line means that you'd cut it off so it wouldn't touch the other line. That's not necessary. Okay, and also in some CAD programs like AutoCAD, in this program also, the dimension is actually associated with the feature. So if I were to go in and change the feature and make it larger and then come back to the draft view, it would automatically show a larger number. If you break the leader line, thus breaking the dimension, it would disassociate itself from the feature, and if you change the feature size, a lot of times the text won't update. You don't want that happening. So don't worry about trying to be too neat, okay? As long as what you can do is the leader line can go through extension lines. It's not supposed to go through dimension lines though, or of course it shouldn't go through text. Nothing should ever go through text. 19. When you dimension a circular feature, you should always dimension with a diameter symbol preceding it. If you're pointing to an arc, anything less than 360 degrees, you should have an R for radius preceding the number. Since a lot of people break this rule, I actually put it down as a rule. Orthographic views, and a section view is an orthographic view, a two-dimensional representation of a three-dimensional object. Orthographic views should have hidden lines turned off in your section views. That's for NX, okay? Our template has hidden lines automatically turned on, so every time you create a section view, you need to manually turn the hidden lines off. If you're hand sketching a section view, just don't put hidden lines in unless they're supposed to be there. There are exceptions to the rule of no hidden lines in sectional views, which we went over last week in sectional views. So those are the things to do correctly. Sometimes the rules are best to write it as a don't. So the dimensioning don'ts are as follows. Don't dimension to a hidden line. If you think you have to, think again. Can you give me another view? Can you give yourself another view showing that feature not hidden, like from the back or something? Or maybe a section view cutting through it to expose the hidden lines. I give you an example of the hidden line in the force support, where that would be an exception. If you have to create a whole new view just to show a dimension on one feature, probably you don't need to. You could dimension to a hidden line. But typically, dimensioning to hidden lines, it's kind of hard to tell what that hidden line is, especially if there's lots of hidden lines in the part. So avoid that whenever possible. Number 22, avoid duplicate dimensioning. That's putting the same dimension of a certain feature in the same view, or twice, or in two different views, like the total height of the part in the front view and in the right side view would not be necessary. Don't over-dimension. Over-dimensioning typically happens when you stack dimensions end to end, the arrowheads end to end, and then give an overall dimension too. That was explained in the PowerPoint notes. Number 23, do not cross dimension lines with other dimension lines or leaders. Okay, position your dimensions so that it's neat and easy to read and it crosses the least amount of lines possible. Number 24, don't crowd your dimensions. Allow ample space around each dimension. Don't crowd it with other text. Don't crowd it against other lines. Okay, try to make it neat and easy to read. Don't use fractions. Of course, the only architectural engineering still uses fractions because we typically don't get any smaller than about 1/8 of an inch. Number 26 is typically my catch-all don't, where most people make sloppy decisions, and that is avoid collisions or overlapping of text with other dimension lines or extension lines or borders or or other text or anything really. Don't crowd things, don't make it sloppy. So make sure you don't break these rules unless you have a really good reason.